I'd like to invite Dr. Mary Ward. Dr. Ward is a senior investigator, National Cancer Institute Division of Cancer Epidemiology and Genetics, Occupational and Environmental. Her title is Nitrate in Drinking Water and Cancer, Appraising the Evidence. Dr. Ward.
Thank you very much. I appreciate the opportunity to speak to you all today on this important day of remembrance and to talk a little bit about my research. I was asked to speak about nitrate in cancer, nitrate in drinking water and cancer in particular, with the idea of potentially doing future research in the Chernobyl affected area. So as Dr. Drost spoke a little bit about, the human population has had large impacts on the global nitrogen cycle. You can see from this graph that since about 1950, there's been very large increases in reactive nitrogen, mostly in the form of chemical nitrogen fertilizers. That's the blue line going up. And as a result of that, the total nitrogen inputs into the environment by humans have now exceeded that of natural nitrogen fixation. This has resulted in increasing levels of nitrate in our water resources around the world. So mostly due to nitrogen fertilizers, but also due to animal and human waste. And as was mentioned, there's a regulatory limit for nitrate in our drinking water supplies. In the USA, that limit is 10 milligrams per liter is nitrate, counting only the nitrogen, and that's roughly equivalent to the EU and WHO regulatory level of 50 milligrams per liter as nitrate, the ion. The highest exposures, because nitrate is regulated in public water supplies mostly, the highest exposures are among the population using private wells, which in the United States are not regulated. And there's not a lot of measurement data to try to assess exposure. I'll be talking a little bit about that at the end of my talk. But why do we care about nitrate ingested from drinking water or from diet? That's because in the body, it's absorbed in the bloodstream and excreted through an active transport system into the saliva, where oral bacteria then reduce nitrate to nitrite. It's swallowed, and then in the acidic stomach environment forms these nitrosating agents that can react with amines and amides that are commonly found in the diet to form nitroso compounds. And these, as Dr. Drost mentioned, are potent animal carcinogens and putative human carcinogens. This reaction can be increased in the presence of heme iron found in red meat, and it is known to be inhibited very successfully by higher levels of antioxidants, such as vitamin C. We also know that nitrate inhibits iodide uptake by the thyroid. And this inhibition has been shown to decrease levels of thyroid hormones, resulting in an increase in levels of thyroid-stimulating hormone. And as I'll show you in a minute, there's been a number of cross-sectional studies that have linked higher nitrate levels in drinking water to thyroid disease. So these studies, which have been mostly cross-sectional, just a few examples here, have pretty consistently shown that elevated nitrate levels in drinking water are associated with thyroid conditions like thyroid hypertrophy in women, and a study in the Netherlands among women. High nitrate levels in water supplies in Slovakia were associated with subclinical hypothyroidism in children. And in a study that we did in the United States, in Pennsylvania, in a cohort of Amish people, we found that higher nitrate levels in private wells were associated with a higher prevalence of subclinical hypothyroidism measured by TSH levels in the blood among women, but not men. The WHO, International Agency for Research on Cancer, evaluated the evidence for ingested nitrate and nitrite in relation to cancer a number of years ago. The literature was reviewed through 2006, and the monograph was published in 2010. I'm going to just briefly touch on the evidence from that review, including the animal studies, the human mechanistic studies, and the epidemiologic studies focusing on drinking water. Animal studies were quite convincing that nitroso compounds cause cancer. Over 300 nitroso compounds have been tested in animal studies, and 90% were found to be carcinogens. And this was the case for over 30 animal species, including all species of non-human primates. Nitroso compounds cause tumors in multiple organs, as shown here, including the thyroid. And that's true for individual nitroso compounds that animals were dosed with, as well as for feeding animals nitrate with an amine source, which is how we would be exposed, mostly in our diet. The human mechanistic studies clearly demonstrate that humans will, first of all, reduce nitrate to nitrite, again, as I mentioned, by the oral bacterial primarily, and that drinking water nitrate can increase endogenous formation of nitroso compounds. This has been shown in a number of controlled feeding studies, and the elevated nitroso compounds have been seen largely at levels exceeding the current maximum contaminant level for nitrate. But one study showed no such increase at levels below that MCL. Another, again, feeding study showed that in humans showed that nitrate intake via drinking water along with an amine source, in this case a meal of fish, increased the excretion of NDMA, which is a carcinogenic nitroso compound. So in terms of the epidemiology studies, the scientists reviewed the evidence for dietary nitrate and nitrite and concluded that dietary nitrate is, there was inadequate evidence for a relationship with cancer, and most studies had focused on stomach and esophagus cancer and generally showed an inverse or no association. Now, the major source of dietary nitrate comes from green, leafy, and root vegetables. These also have protective micronutrients that have, again, in human biomonitoring studies, have been shown to inhibit this formation of nitroso compounds in the body. There was limited evidence for dietary nitrite, especially from processed meats. And again, at the time of the monograph review, most studies were of stomach and esophagus cancer, and most showed positive associations. Since that review, there have been additional cancer sites that have shown increased risk with dietary nitrite from processed meats, including the colorectum, kidney, ovary, and thyroid. For the drinking water studies, it was concluded there was inadequate evidence of carcinogenicity in humans for nitrate in drinking water. And I have a quote here from the monograph review that epidemiologic studies of any one cancer site were few. Exposure levels tended to be low because they were mostly focusing on public water supplies, and endogenous nitration factors were not often considered. Now, since that monograph, since that literature was reviewed a little over 10 years ago, there have been additional studies that have seen positive associations with stomach, colon, and kidney cancers, no association with brain and bladder. But I know of particular interest is what do we know about thyroid cancer and thyroid conditions. So I want to just talk about some recent and ongoing research at the National Cancer Institute, where we're looking at drinking water nitrate and cancer in 2 cohorts. I'll be showing some results from the Iowa Women's Health Study, which is a cohort of older women in Iowa, which is a highly intensely agricultural state in the U.S. 73% of the women used public supplies, 25% were on private wells at their home, and a small percent on bottled water. The other study is the Agricultural Health Study, which is a study of 90,000 pesticide applicators and their spouses, also in Iowa and another agricultural state, North Carolina. And in this cohort, it's quite unique because the large majority of the participants use private wells for their drinking water source. And as I mentioned, those aren't regulated, so we don't have good measurement data on the cohort. So I'll just be talking briefly about how we're assessing exposure for this cohort by using GIS-based models. So first, the Iowa Women's Health Study is located, as you can see here, in an area with high inputs of nitrogen. This is kind of the upper Midwestern part of the United States, sometimes called the Corn Belt, and there's a lot of nitrogen fertilizer use on corn crops in particular. We had information on their drinking water source and duration of how long they use that source. The cohort was, that information was obtained in 1989. And we assessed exposure for the women who were using public water supply by linking a public database of monitoring measurements of nitrate as well as disinfection byproducts measured as trihalomethanes. We linked those to the city of residence of the woman. There were over 470 cities, and we linked also by the duration that they were living at that home. We calculated exposure metrics, including the average level of the nitrate in their drinking water and also the trihalomethanes, and the years they were exposed at half the maximum contaminant level or above. So this was a very stable population. Over 82% of the women had used their water supply for more than 16 years. So what did we find for drinking water and thyroid cancer and thyroid disease? To my knowledge, this is the first study that evaluated drinking water nitrate and these health outcomes. We found that thyroid cancer and dietary nitrate was associated with an increased risk of thyroid cancer. These are approximate quartiles of intake in milligrams per day, with the highest group showing an almost threefold increased risk in thyroid cancer. I should say this was based on only 40 cases at the time we did this study in 2009. Nitrate in drinking water was also associated with an increased risk of thyroid cancer, with about a twofold increased risk in the highest quartile of exposure. That's a long-term average exposure to nitrate in their drinking water. There was no, we didn't have information on levels in private wells, but there was not an increased risk among the group who used private wells for their drinking water. We also saw that there was an increase in prevalence of hypothyroidism among women who had higher drinking water and dietary nitrate levels. This is summed their intake from both diet and drinking water. And that was adjusted for known risk factors for hypothyroidism. So that's basically the summary to my knowledge, of the literature on this topic for drinking water and nitrate and thyroid cancer and thyroid disease. I'd just like to talk a little bit about some other cancers. We've been, again, following this cohort and evaluating a number of cancer sites, and the strongest associations to date have been for ovarian and bladder cancers. With over 20 years of follow-up, we have over 300 ovarian cancer cases and 263 bladder cancer cases. We were able to look at other drinking water contaminants like trihalomethanes, as I mentioned, and assess interaction by factors like vitamin C and red meat, as well as smoking. We also assessed intake of dietary nitrate from processed meats and other sources. For ovarian cancer, we saw an increased risk with increasing average nitrate levels in the public water supply and an elevated risk among women who use private wells. When we stratified by their intake of vitamin C, which again can inhibit the formation of nitroso compounds, we saw that among women who had higher vitamin C intakes, there was no elevation in risk with increasing average nitrate levels in the water. But among women who had lower vitamin C intakes, indeed there was a significant positive trend in risk, and also a significant elevated risk among women who use private wells for their drinking water. And this interaction was statistically significant. We also found that bladder cancer risk was increased among women who, this shows the metric of looking at duration of years above half the maximum contaminant level. And when we adjusted for trihalomethanes, which are a known bladder cancer risk factor, we did not see any change in risk. So it seemed to be an independent association with nitrate. Some additional analyses that we've done included kidney cancer, where we saw an increased risk with average nitrate levels and years over half the MCL. But for colon, rectum, and pancreas cancer, we've seen no associations with drinking water nitrate level in the cohort. So these kind of exposures are somewhat difficult to follow up on because although nitrate is a common water contaminant, you really have to go to study populations in agricultural rural areas of the country or world to really assess these exposures. So we are looking at this in the agricultural health study cohort, which is, as I mentioned, study of applicators and pesticide applicators and their spouses in Iowa and North Carolina. And the large majority use private wells for their drinking water, but we do not have measurement data for those wells. So we took an approach of using a GIS-based, Geographic Information System-based model to estimate nitrate in their private wells. We know various factors such as the depth of the well, land use, particularly corn agriculture, the presence of animal feeding operations near a well, and the aspects of the geology are all predictive of nitrate in the groundwater. So using this modeling approach, a particular type of model, random forest, actually performed better than linear regression. We found that 66 variables explained 77% of the variation in the nitrate concentration, and I've just listed some of the key variables here in terms of in their order of importance for predicting nitrate. So this model is published, and we are in the process of applying it to the cohort. This shows just what the exposure pattern looks like for the cohort. There's nitrogen applications across all of Iowa. There's corn agriculture pretty much every county in Iowa, but you can see the pattern of higher nitrate, which is the kind of the deeper colored dots, is really quite not uniform at all. It's highest in the western part of the state, that's shallow wells in the top map. And in the deeper wells, you see the contamination in the northeast part of the state where there's the karst geology. So in terms of ongoing research, in the Iowa Women's Health Study, we also hope to estimate levels for women using private wells, and we're doing additional analyses, including gastrointestinal tract cancers. And in the Agricultural Health Study, we will be conducting analyses of all of these cancers here, including thyroid cancer and thyroid disease. And hopefully these results should help clarify cancer risk at levels between 5 and 10 milligrams per liter and above the MCL, which the Agricultural Health Study cohort has exposure above those levels. So just a little bit about future studies and research needs. Certainly, we need to evaluate additional factors that influence endogenous nitrization. The oral microbiome can be measured in saliva or buccal cell samples from epidemiologic studies, from study populations. You can also incorporate biomarkers to measure urinary levels of nitroso compounds and nitrate. And certainly, it's very intriguing, this idea to evaluate the interaction with radiation exposure and its potential effects on thyroid disease and thyroid cancer. So with that, I'd just like to acknowledge a few of my co-authors on some of these studies I presented.
Thank you very much, Dr. Ward, for this presentation, and also want to commend you on your really groundbreaking work in this field.